Imagine our planet, a blue marble in the vastness of space, spinning silently as it journeys around the sun. From above, Earth looks peaceful and unchanging, but beneath the surface, powerful and invisible forces are constantly at work, shaping the climate that makes life possible. These forces drive the weather we experience every day, from gentle breezes to violent storms, and they are responsible for the delicate balance that keeps our world habitable. But what if that balance were to shift? Deep within our oceans lies a massive, slow-moving current known as the Atlantic Meridional Overturning Circulation, or AMOC. This vast conveyor belt of water moves heat from the tropics toward the poles, playing a crucial role in regulating global temperatures and weather patterns. Recently, scientists have sounded the alarm. The AMOC appears to be weakening. This isn't just a scientific curiosity, it's a development with potentially profound consequences for our climate and our way of life. If this current slows dramatically or even stops, the effects could be catastrophic. Parts of the northern hemisphere, including Europe and North America, might experience much colder winters, harsher storms, and even the onset of a regional ice age, transforming familiar landscapes into frozen frontiers. The science behind these predictions is complex and still debated among experts. Some researchers argue that the risk is immediate and urgent, while others believe the changes will unfold more gradually. But one thing is clear, the potential impact is significant enough that we cannot afford to ignore it. To truly grasp what's at stake, we need to understand how the AMOC functions, how it has shaped our climate for thousands of years, and how human activities, like burning fossil fuels and polluting our oceans, are now threatening to disrupt this ancient system. One of the most alarming changes is happening in Greenland, where vast glaciers are melting at unprecedented rates. The fresh water pouring into the North Atlantic is diluting the salty ocean currents, potentially throwing the AMOC off balance and accelerating climate change. As we investigate this unfolding mystery, we'll hear from leading scientists around the world. Some warn that a tipping point could be closer than we think, while others urge caution and further study. The debate is ongoing, but the stakes could not be higher. This is more than just a story about ocean currents. It's about the intricate and fragile machinery of our planet's climate and why understanding it matters to every single one of us, no matter where we live. The AMOC, or Atlantic Meridional Overturning Circulation, is often described as a giant conveyor belt in the Atlantic Ocean. It plays a crucial role in moving vast amounts of water across the globe, transporting warm, salty water northward from the tropics, and bringing cold, dense water back south. This powerful system is one of the main engines driving Earth's climate and weather patterns. As the AMOC moves warm water north, it also carries cold, dense water south beneath the surface. This deep, cold current travels silently and steadily, shaping the temperature and chemistry of the Atlantic Ocean. The journey begins in the tropics, where the sun's intense heat warms the surface waters. As the water heats up, it also becomes saltier due to evaporation, making it lighter and more buoyant at first. This warm, salty water travels northward, carrying energy with it. As it moves, it releases heat into the atmosphere, which is a big reason why Europe enjoys much milder winters than places like Canada, even though they are at similar latitudes. The AMOC acts like a hidden hand, redistributing warmth and shaping regional climates. When this water reaches the cold regions near Greenland, it cools rapidly. The drop in temperature combined with its high salt content makes the water denser. Eventually it becomes heavy enough to sink deep into the ocean, plunging thousands of meters below the surface. This sinking action is vital. It acts like a pump, pulling more warm water northward to replace what is sunk. This continuous movement keeps the entire circulation going, connecting distant parts of the ocean in a never-ending loop. The cold, deep water then flows southward, traveling all the way toward the southern hemisphere. Eventually, it rises again, warms up, and the cycle begins anew, driving the global ocean conveyor belt. For thousands of years, this circulation has shaped not just climates but also the rise and fall of civilizations along the Atlantic. It has influenced where people settled, how they traded, and even the crops they could grow. The AMOC is like our planet's natural thermostat, connecting distant oceans and helping to regulate weather patterns across continents. Its influence stretches far beyond the Atlantic, affecting rainfall, storms, and even the stability of ice sheets. But this entire system depends on a delicate balance of temperature and salt. Even small changes in either can have big consequences, tipping the scales and altering the flow. If that balance is disrupted by melting ice, changing rainfall, or warming oceans, the whole engine could slow down or even stall, with dramatic effects for our climate and way of life. Greenland's melting ice is more than just a distant spectacle, it's a powerful force reshaping our planet's climate system in real time. Every year, billions of tons of ice break away from Greenland's vast ice sheet, tumbling into the frigid North Atlantic. This meltwater floods the North Atlantic with fresh water, diluting the salty ocean, and subtly but steadily altering its chemistry and density. Because fresh water is lighter than salty water, it forms a buoyant layer on the ocean's surface. This layering acts like a lid, blocking the normal sinking of warm, salty water that drives the Atlantic Meridional Overturning circulation, or AMOC. If this sinking process slows or stops, the AMOC's powerful engine sputters, threatening to disrupt the entire system of ocean currents that regulate our climate. Scientists warn that if Greenland's melting continues at this pace, enough fresh water could be added to the ocean to shut down this vital circulation entirely, a scenario with global consequences. This isn't just a theoretical risk. By studying ancient ice cores and ocean sediments, researchers have found clear evidence that the AMOC has collapsed before, often following massive floods of fresh water from melting ice sheets. When this happened in the past, it triggered abrupt and dramatic climate shifts, plunging regions into deep freezes, causing wild swings in weather, and transforming entire ecosystems almost overnight. The big question now is, how close are we to reaching that tipping point again? Scientists are racing to find answers, monitoring ocean currents and ice melt with growing urgency. The AMOC has a critical threshold. Push it too far, and it can flip from strong to weak, or even shut down completely with little warning. Today, the rapid pace of ice melt is testing that threshold like never before, raising alarms among climate scientists worldwide. The risk is that we're approaching a point of no return, a moment when the system could tip, and the consequences would be irreversible for generations. If that happens, the impacts could be swift and severe, reshaping weather patterns, coastlines, and the lives of millions across the globe. If the AMOC collapses, Europe could see winters plunge by 5 to 10 degrees Celsius, like a regional ice age. North America would also feel the chill, while global weather patterns shift unpredictably. Storms could intensify, droughts could worsen, and rainfall patterns could be thrown into chaos. Monsoons in Africa and Asia might weaken, threatening water supplies for billions. Sea levels along the U.S. East Coast could rise rapidly, as the Gulf Stream's pull disappears. The ocean's health would suffer, less oxygen and nutrients would reach the deep sea, disrupting marine life and fisheries. The food web could unravel, threatening ecosystems and economies. These changes wouldn't just be local, they'd ripple across the globe. The AMOC is a backbone of our climate. Its collapse would reshape life as we know it. The stakes couldn't be higher. When could this happen? That's the heart of the scientific debate. We've only measured the AMOC directly since 2004, so long-term trends are hard to pin down. Some scientists warn a collapse could happen within decades, pointing to patterns in sea surface temperatures and rapid ice melt. Others argue that, while the AMOC is weakening, a total shutdown this century is unlikely. Most models show only gradual decline. Both sides agree. Adding fresh water weakens the AMOC, and a weaker AMOC means serious climate consequences. The real question is how fast and how soon. The answer will shape how urgently we need to act. Some scientists see early warning signs that the AMOC is losing stability fast. A 2025 study found a fingerprint in ocean temperature and salinity data, suggesting the system is nearing its tipping point. For countries like Iceland, this isn't abstract, it's a national security threat. History shows the AMOC can flip states in just decades, not centuries. Critics argue that mainstream climate models may be too conservative, missing feedback loops that could speed up collapse. For example, more sea ice could reflect sunlight, causing further cooling and accelerating the process. The warning: the AMOC may be more fragile than we think. Ignoring these signals could be a costly mistake. Not all scientists see an imminent collapse. Many argue that the threat is real, but likely further off. They point to climate models showing the AMOC weakening, but not shutting down before 2100. Some question the reliability of using old sea surface temperature records as proxies for AMOC strength. Natural cycles like the North Atlantic Oscillation can temporarily mask or offset human-driven changes. Recent NOAA studies show the upper AMOC may have stabilized for a time, even as the deep current continues to weaken. The skeptical view expect a gradual decline, not a sudden catastrophe. But even a slow weakening brings risks: rising sea levels, shifting weather, and deep ocean changes. The call is for careful monitoring and better models, not panic. The debate is about timing, not whether change is coming. To see the future, we look to the past. Earth's climate has swung between ice ages and warm periods for millions of years, driven by slow changes in our orbit. We're still technically in an ice age, but living in a warm, interglacial phase. The AMOC has switched on and off before, shaping the climate that allowed civilization to flourish. Today's changes are different, driven by rapid greenhouse gas emissions, not slow orbital shifts. The AMOC is not permanent, it's changed state before, sometimes abruptly. Our current experiment, pushing the climate system faster than ever, has no precedent in the geological record. The lesson: Earth's climate can shift dramatically, and we're testing its limits now. The stakes are higher than ever. So, is a new ice age coming? No, but a collapse of the AMOC could bring severe regional cooling, even as the planet warms. The AMOC is weaker now than it's been in 1,000 years, and fresh water from melting ice is making things worse. The timing and speed of future changes remain uncertain, but the risks are growing. This isn't just a scientific debate, it affects food, water, sea levels, and ecosystems worldwide. Our actions, especially burning fossil fuels, are pushing the climate's machinery to its limits. The AMOC's fate is a warning. We must act wisely and urgently to protect our planet's delicate balance. By understanding and respecting these powerful forces, we can better prepare for what's ahead. The choices we make now will shape the climate and our future for generations.